Hi, welcome to my video on proofs with rectangles. Proofs on rectangles. The definition of a rectangle: a quadrilateral with four right angles or four 90-degree angles. A, B, C, D is a quadrilateral with four right angles marked by the little boxes in the corners. Angle A, B, C, D are right angles as we shown here. Let's do a proof. Proof: if a quadrilateral has three right angles, then it's a rectangle. And the proof goes something like this before we start. If you have three right angles, then you have four right angles, therefore you have a rectangle. So we'll establish the fact that if we got three, we have four, we have a rectangle. Here we go. PQRT is a quadrilateral, so PQRT is a quadrilateral. I'll put that in the given also. And as a result, we're given that we have three right angles, so PQRT are right angles. We're going to prove that PQRT is a rectangle. So angle P, angle Q, angle R are right angles. And that's a given. That means that angle P is 90 degrees. Angle Q is equal to 90 degrees. Angle R is equal to 90 degrees. And that's the definition of a right angle. As right angles are equal at measures of 90 degrees. So now we have to say that angle P plus angle Q plus angle R plus angle T is 360 degrees. And the reason, the sum of the interior angles of a quadrilateral is 360 degrees. We've done units on polynomials, so that was worked out in those polynomials, or that videos on the polynomials. Number 4, angle P is 90, so we'll put 90 in. Angle Q is 90, so we'll put 90 in the place of Q. Angle R is 90, so we'll sub 90 in the place of R. So that's a substitution. We're subbing 90 in the place of those angles. And if we add them up, 3 90s is 270. So that's addition. We're adding up the angles. And now we'll do a subtraction. So we got 270, take 270 off of each side and we get a 90 left. So that's subtraction, property of equality. And as a result, we have P, Q, R, T is a rectangle. Because we have three right angles given, we prove that the fourth one is I forgot to say that, just a little technical part, that angle T is a right angle, and that's by definition of a right angle. Then this is number 8. So we got three right angles here. We have the fourth one a right angle. So this is the definition of a rectangle. As a rectangle has four right angles. So now you don't need to prove four right angles to be a rectangle. You just need to have three right angles because there is a fourth one automatically. So that's the proof. If a quadrilateral has three right angles, then it's a rectangle. Another proof. Again, you can pause the videos and work these out if you wish. Your choice. A rectangle is a parallelogram. So A, B, C, F is given as a rectangle. Prove that A, B, C, F is a parallelogram. Well, we're given that A, B, C, F is a rectangle. Okay. That means that that's a rectangle. That means that we have angle A, angle B, angle C, and angle F are right angles. And that's the definition of a rectangle. And since we have four right angles, that means angle A is equal to angle C, and angle F is equal to angle B, because all right angles are equal. And number 4, that means that A, B, C, F is a parallelogram because we have two pairs of opposite sides, or no, two pairs of opposite angles equal. What am I saying sides for? Sorry about that. Two pairs of opposite angles equal. Angle A is equal to angle C. Angle F is equal to angle B because they're right angles. So A, B, F, C is a parallelogram. Two pairs of opposite angles equal, not sides. The sides are equal too, but this right now we proved it with angles, opposite angles equal. And a rectangle has all the properties of a parallelogram. A rectangle is a parallelogram, so the properties of a parallelogram are also the properties of a rectangle. So every rectangle has opposite sides parallel. Every rectangle has opposite sides equal, and it has opposite angles equal, and it has one pair of opposites. No, I better not say that. I better say that the diagonals bisect each other. The diagonals bisect each other in a rectangle, so they also bisect in a parallelogram, and also the consecutive angles are supplementary. So a parallelogram, the consecutive angles A and B are supplementary. So that's true of a parallelogram, so it's true of a rectangle. And the diagonals, if you draw the diagonals FB and AC, then they're going to be bisecting each other in a whatever a parallelogram has, a rectangle has. Let's continue. Let's do some proofs. Again, pause the video and work these out. We have a diagram in which it says that MATH is a rectangle. MATH is a rectangle. Angle 1 is equal to angle 2. We want to prove that ME equals AF. So if I can, looks like if I get these two triangles HME congruent to TAF, then we'll get ME equals AF. So how do we do that? We use the properties of a rectangle to get the sides equal, get the angles equal, and we got parallel sides right here in the rectangle. So we got alternate interior angles equal right here. So that means that these are going to end up to be equal. And we got triangles congruent. We got a CBC, TC. So angle 1, let's put a 3 here. and a 4 here. So here we go. Let's do the proof. Let's say that MATH is a rectangle, and that's the given. So what properties do we have equal in the triangle? Well, let's see. I have MH equals AT because the opposite sides of a rectangle are equal. And we have MA parallel to HT because the opposite sides of a rectangle are parallel to each other. Based on that, because they're parallel, that means that angle 1 equals angle 3 and angle 2 equals angle 4, and that's parallel line theorem, and their form is Z, so they're Z alternate interior angles across the transversal, so alternate interior angles equal. And because we're given that 1 equals 2, it follows that 1 equals 3, 2 equals 4, 1 equals 2. That means 3 must equal 4 by transitive property, or few transitive properties, more than one. So we have these two angles equal. We have 1 equals 3 and 2 equals 4. And that means that 3 is equal to 4. We have opposite sides. We need, we have angle M and angle A are right angles. Definition of a rectangle. As a rectangle has a right angle. Rectangle has 4 right angles, but I only need to look at these two, angle M and angle A. That means that angle M is equal to angle A because all right angles are equal. That means I have the triangles congruent, and the triangles are HME congruent to TAF, and that's, remember now we have these two sides equal. We have this angle is a right angle, this angle is a right angle, 3 is equal to 4, so the triangles are congruent by AAS, angle side congruency, and as a result we have ME equals AF. CPCTC, corresponding parts of congruent triangles congruent. Okay, if you wish, let's do another proof. Pause your video and see if you can work this one out. We have RECT, it's a rectangle. We have YT equal to VC, YT equals VC, and we have to prove that XYV is an isosceles, and let's say an isosceles triangle. Triangle is isosceles, and an isosceles triangle has two sides equal. So how am I going to get these two sides equal? Well, if I can get these two angles equal right here, then the sides would be equal by converse of ITT. How do I get these sides equal? Well, how do I get these angles equal? Sorry, I get the sides equal because of equal angles. And I notice that 1 and 2, 3 and 4. I notice that these are equal, VOAT. These are equal, VOAT. So I need to get, in order to get 2 equals 3, I need to get 1 equals 4. That means I have to get a pair of congruent triangles here. I already have these segments equal, and I can have these equal. RT equals EC, because they're the opposite sides of a rectangle. And I have an angle here, no more, so, yes I do. I got a rectangle, so I have a right angle. So these are right angles, but if I say these right angles are equal, then I'll have an ASS. And remember, I'll put it right here, an ASS and an AAA are not used in proofs. We can have an AAS, ASA, SAS, SSS, HL, but we can't have ASS or an AAA. That's incongruent triangles. So we say these are right angles, and because they're right angles, we have right triangles here and here. Therefore, these triangles can be congruent by H, hypotenuse, leg, HL. So, proof done. Triangles can be congruent. Angle 1 is 4, and from there we keep going. Here we go. Got the proof done. Number 1 is YT equals VC given. I could put 2 of them in the same, but I didn't. RECT is a rectangle given. And now we're going to use the properties of that rectangle. We have RT equals EC, opposite sides of a rectangle are equal, because a rectangle is a parallelogram. And we have the 2 sides, and we have to say that angle R and angle E are right angles. Because we have a rectangle, then that's the definition of a rectangle. The rectangle has 4 right angles. That means that angle R is equal to, I can't say equal, because then I'll have an ASS, so can't do that. I have to say that triangle TRY and triangle CEV are right triangles. Definition of right triangles. Remember, I was going to say they're equal, but that would end up with an ASS. So I have to say they're right triangles, and because I have right triangles, then the triangles can be congruent. So the triangles are TRY is congruent to triangle CEV. These 2 triangles are congruent. This is a 5, be careful. This is a 5. This is a 6 by HL. Congruency. That's hypotenuse leg. This is the hypotenuse opposite the right angle. Hypotenuse opposite the right angle. These are the 2 legs. So HL. And as a result, we have angle 1 equals angle 4. CPCTC. And angle 1 equals angle 2. Angle 3 equals angle 4 because of VOAT. And hence, we have angle 2 equals angle 3 by transitive property a few times. And that leads us to, extend that down, that leads us to x, y equals xv, and that's the converse of the ITT. So the ITT is the isosceles triangle theorem, which means that if you got an isosceles triangle, two sides equal, you get two angles equal. The converse is the reverse. If you got two angles equal, then you got two sides. So two angles equal in the triangle, the sides opposite them are equal. That's the converse of the ITT. And as a result of the two sides equal, that means that triangle XTC is isosceles. And the reason, definition of an isosceles triangle. Two sides equal, triangles isosceles. So, a few more proofs done. And the more proofs you do, hopefully the better you get. Proofs are, sometimes students find proofs difficult to do. But the more practice, the more thinking you do, the better you get. So let's do some more proofs. Prove a parallelogram with a right angle is a rectangle. A parallelogram with a right angle. So we're given that EFGH is a parallelogram. And we're given that it has a right angle. So we're given that angle H is a right angle. So I could have said angle E or angle F or angle G is a right angle. And we have to prove that the parallelogram is a rectangle. So EFGH is a rectangle. So how do we prove? We have a parallelogram with but a rectangle has four sides. Sorry, a rectangle has four right angles by definition. But we don't need to prove the four of them. We only have to prove that three of them are equal. So we already have one. So angle H is a right angle. So there's one right angle that's given. So I need to get two more right angles. Because if I got three right angles, I have a rectangle. Because three right angles gives you four right angles. So I have EFGH is a parallelogram. Given. Remember, don't forget to pause your proof. You can pause it and work it out and press playback to see if you get it right. Here we go. So I have angle F is equal to angle H because the opposite angles of a parallelogram are equal. That means that angle H is equal to 90 degrees. Definition of a right angle. Angle H is a right angle, so angle H is equal to 90 degrees. Definition of right angle. So that means that angle F is equal to 90 degrees by, you can say substitution or you can say transitive, whatever you wish, your choice, substitution or transitive property. So that means that angle F is a right angle. Definition of a right angle. So now I have one right angle at H, I have another right angle at F. How am I going to get a right angle, another pair? But so we have that, we got H and F, so I need to get one more. So let's say that angle H is supplementary to angle G. And the reason is that the consecutive angles of parallelogram are supplementary. We proved that earlier. And that means that angle H plus angle G is equal to 180 because of definition of supplementary angles. So number 9 is that angle H is 90 degrees. So we'll put 90 in the place of angle H by substitution. So that means that angle G is equal to 90 by subtraction. And number 11, angle G is a right angle. Definition of a right angle. And so that we have E, F, G, H is a rectangle. We can't say definition because we have what? 3 right angles. A parallelogram with 3 right angles is a rectangle. We did that proof earlier on. So you don't need to prove 4, you can prove 3. So that proof is done. But notice I had to go and pick up 2 more, excuse me, 2 more right, excuse me, 2 more right angles. Number 4 proof. Let's look at this one. So we have MH is perpendicular to MA. MH is perpendicular to MA, right here. XM equals XM, right here, equals TY. And XAYH is a parallelogram. So I need to prove that MATH is a rectangle. So to get a rectangle, I need a right angle, because a parallelogram with a right angle is a rectangle. So if I have XAYH, a parallelogram, I'm going to use their properties to get MATH is a parallelogram, and then we have a right angle here. So we got a rectangle. So here we go. So let's say that MAYH is a parallelogram. XAYH is a parallelogram given. Number 2, that means that XA is parallel to HY, and that's the definition of a parallelogram. Opposite sides parallel. And we have XA equal to HY because the opposite sides of a parallelogram are equal, and we have MX equals TY given. So as a result, let's put it right here. So how am I have these two equal? How am I going to get to this side equal? I already have XA parallel to HY, which means that includes, that says that MA is parallel. So I already have this side parallel right here. So I will take XA and add on MX and take HY and add on TY as addition, property of equality. And now we know that MA is equal to MX plus XA, and that HT is equal to HY plus YT, and that's the segment addition property. Segment addition property. And notice that MX and XA is right here, and HY and YT is right here. So these are equal. These two are equal to those two. There they are right there. So that means that MA equals HT by, that's the number 7, gotta be careful, by substitution, or you could say transitive, either or, substitution, or you could say transitive. Transitive might be better, but check with your teacher which is transitive. Again, those two, these two are equal to these two, that they are there, so that's the transitive property, or you get away with a substitution. Number 8, that means we have MATH is a parallelogram. We have one pair of opposite sides, parallel and equal, and that's in, they're parallel in number 2 and they're equal in number 7. Now we have, that's an 8, so let's do a 9. So we need to get a right angle. So we're told that MH is perpendicular to MA, given. So MH perpendicular to MA, that means that angle M is a right angle. Definition of perpendicular segments or lines. Lines are segments that are perpendicular form right angles. And as a result, we have a right angle. That means that MATH is a rectangle. The reason? There it is up there, parallelogram with a right angle is a rectangle. Parallelogram with a right angle is a rectangle. So, hopefully your proofs, you're seeing what I'm doing and writing the reasons out, and everything is going okay. So again, some students have trouble with proofs, and the more you do, the better you get. So let's do some more. Prove the diagonals of a rectangle are equal. So the diagonals of a rectangle, so that means that MATM, make that an A, MATH is a rectangle. And MT and HA are diagonals. So that means we got to prove that the diagonals, which are MT and HA, we got to prove that MT equals HA. Diagonals are going to be equal. So how do we do the proof? Well, what I do, I'm going to draw the diagram separately down here so we can see it like this. And we'll do the other one like this. Because what happens is the diagrams are overlapping. So if I want to prove that MT equals HA, I'm trying to draw these two triangles separately so that you can see it. Here they are, separate. So I'm trying to prove that MHT is equal to ATH because these are the diagonals here, and these are the triangles that have them in it. So here we go. Now, I need to get these triangles equal. So I have MATH is a rectangle. And the reason is given. So in a rectangle, I have MH is equal to AT, opposite sides of a rectangle are equal. So I got that side equals that side. And I have, notice, I have these two equal, so I'll mark them here. Now I have a rectangle. That's a right angle there, and that's a right angle there. So I'll say these are right angles, and then I'll have them equal. So angle, and I have to use 3 letters because of this diagram, that M, H, T, and angle ATH. They're right angles. That's because you got a rectangle. That's the definition of a rectangle. Rectangle has 4 right angles. And as a result, we have that MHT, angle MHT is equal to angle ATH. All right angles are equal. So we have MHT equals ATH, and we have this side right here. So that means HT is equal to TH because of a common side. Common side. Notice I had to go HT, TH, because the H goes with the T and the T goes with the H. They're not. It's not HT, because they're twisted. If you did these two triangles and laid them on top of each other, H would fall on T and T would fall on H. So the triangles MHT is congruent to the triangle ATH, and it's a SAS. Congruency. So that makes that MT is equal to AH CPCTC. Corresponding parts of congruent triangles congruent, and these are the two diagonals. So the diagonals of a rectangle are equal. And number 6, prove a parallelogram with diagonals equal as a rectangle. A parallelogram with diagonals equal is a rectangle. So we're given that P, Q, R, S we're given a parallelogram. Parallelogram. So P, Q, R, S is a parallelogram, and the diagonals are equal, so we have PR equals SQ, and so we have to prove that PQRS is a rectangle. So we're given a parallelogram with diagonals equal, we have to get a rectangle. So how are we going to get, we got a parallelogram, we did before, if a parallelogram has a right angle, then we have let's see, okay, here we go, PQRS is a parallelogram given, and we have, let's see, we have PS equals QR, opposite sides of a parallelogram are equal. We have SR equals RS. Common side, and also that we have PR is equal to QS, because the diagonals the diagonals are not equal, because diagonals, oh yes, diagonals are equal, and that's a, what am I doing? That's a given. We're given right here, the diagonals are equal. So the triangles are congruent. What triangles? Here we go. Triangles PRS is congruent to triangle QSR by SSS congruency. We got the three sides. There they are. PS equals QR. This is common side, and we got this side, and that's done. Again, if you drew the two triangles separately like this, so this is PRS, and this is QRS. So we have these equal, we have this is common, and we have this diagonal is equal to that one. So SSS, so that means we have the angle PSR is equal to the angle PSR is equal to QRS CPCTC. Now we're given a parallelogram, so we know that the angle make that a P, my mistake, PSR is supplementary to angle QRS, because the consecutive angles of a parallelogram are supplementary. Okay, number 8, we have that PSR plus angle QRS equals 180 degrees. Definition of supplementary angles. So angle PSR plus angle, remember they're equal, so QRS is being replaced with angle PSR by substitution, and that substitution is occurring in number 6, where they're equal, and number 8. So we're taking away PRS is equal to, we're taking QRS, which is right here, is equal to PRS. So I'm replacing QRS with PRS right here by substitution. And that means that 2 PSR angles, 2 angles of PSR, be careful, equal 180 by addition. We added these two together to get 2 of them, and then angle PSR equals 90 by division, property of equality, and that means that angle PSR is a right angle. Definition of a right angle. And so that PQRS is a rectangle because a parallelogram with parallelogram with a right angle is a rectangle. Proof that we did earlier. We have a parallelogram. Parallelogram is given, and we have a parallelogram with a right angle. There's the right angle, so that's, we look at 1, and you look at 12. 1 and 12. We got a parallelogram with a right angle. We got a rectangle. So that ends the proofs with rectangles, dealing with PLTs, dealing with congruent triangles, and dealing with the properties of parallelograms, the properties of rectangle. Remember, a rectangle is a parallelogram, so a rectangle has all the properties of a parallelogram. The diagonals are equal. Some new ideas, statements. And if you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.